You may pause and try this question. All right, let's take a look. If y is the smallest positive integer such that 3150 multiplied by y is the square of an integer, then y must be 3150 multiplied by y is the square of an integer. This is equal to k square, where k is some integer. And y is the smallest such number, smallest such positive integer. Wonder why that's relevant. To start off, let's just take some smaller value than 3150 to understand what's going on. We'll build from that and then come back. So let's say instead of 3150, we had 18 as the number. Let's say I've just picked a random number. If y is the smallest positive integer such that 18 multiplied by y is the square of an integer. Let's now use a different variable, j. Then what would y be in this case? 18 times y equals j square. Well, 18 times 18 is a perfect square. So can't y be 18? Well, there's one reason why y can't be 18. The reason is that we're looking for the smallest positive integer that satisfies the given condition. Now the question becomes, is 18 the smallest such number that when multiplied by 18 gives us a perfect square? No, 18 is not the smallest such number. Now, how do we figure out what is the smallest number, and how did I know that 18 is not the smallest number? That's the crux of the question. 18 itself is not a perfect square. Otherwise, y would have needed to be 1. 18 is not a perfect square. But what's the smallest number that I need to multiply 18 with to get a perfect square? Now, the idea here is that I need to look at the prime factorization of 18. I need to look at the prime factors of 18. Let's do that. 18 can be split into 2 and 9. And then 9 is nothing but 3 square. So 18 is 2 times 3 square. 3 square, interesting. So 18 has a factor which has 2 powers, 3. So 3 is already squared. One of the factors already is a square. 2 isn't. There's only 1 2. So what would I need to multiply 18 by? I would need to multiply 18 by 2 to end up with 2 square times 3 square, which is nothing but 2 times 3, 6 square. 18 times 2 is indeed square of an integer. So what's the underlying concept that's being used here? Square of any integer can be represented as the various prime factors of that integer with even powers. Not necessarily a power of 2, there could be a power of 4 or 6, but an even power. For every perfect square, its prime factorization can be written in the form of the prime factors, each prime factor to an even power. So now for our question, what we need to do is figure out the prime factorization, figure out which prime factors do not have even powers, and we need to convert those prime numbers into even powers. So basically, we need to multiply by those prime numbers. That will give us the smallest possible value of y. So what's the factorization of 3150? 3150 is nothing but 315 times 10. 315, let me split this into 5 times how much? 31, that's 6, 30, and then 15, 63. 63 is nothing but 9 times 7, so 7 times 3 square. And then 10 is nothing but 2 times 5. Various prime numbers, 2, 5, 3 square, 7, and 5. I noticed that 3 square is the only prime factor with an even power. So to make 3150 times y into a perfect square, y would need to have a 2 in it, it would need to have a 5 in it. Actually, my bad, there are already 2 5s. 5 times 5, that's 2 square. So that's taken care of. Y would need to have a 2 in it, and y would need to have a 7 in it. That's it. So 3150 times 2 times 7 would be a perfect square. So what's the smallest positive integer? Y, such that 3150 times y is a square of an integer? Well, y needs to be 14. The answer is E.